Good morning and hello everyone. Welcome to our kitchen lab.
Welcome to a delicious lesson in chemistry. I'm Richard.
And I'm Daniel. And for our semester assignment, we're going to explain the core concept of stoichiometry.
And we're going to do it by making pancakes. You see, a chemical equation is just like a recipe.
Exactly. This recipe right here is our balanced chemical equation for pancakes. Now what do we have here, Richard?
We're going to measure 1 cup of flour. We have 2 eggs. We're going to measure 1/4 a cup of sugar, half a teaspoon of baking powder, and 1/4 a cup of oil.
And our yield is going to be 8 pancakes.
The ingredients are our reactants, and the delicious pancakes are our products. Just like in chemistry, the amounts are fixed and have specific relationships. This is the heart of stoichiometry.
Now, we're going to explain ratios and proportional relationships.
Stoichiometry is all about ratios. For example, the ratio of our flour to eggs is 1 cup to 2 cups. You can write this as 1 to 2.
And just like you can scale a recipe up to feed more people, you can scale a chemical reaction up or down to make more or less product, as long as you keep the ratios the same.
Let's test it. Our recipe makes 8 pancakes. If we have 4 eggs, how many pancakes can we make? 4 eggs times 8 pancakes divided by 2 eggs equals to 16 pancakes.
See, we use the egg to pancake ratio as a conversion factor, just like mole ratio in chemistry. We only had 1/4 cup of flour. We only had 1/4 cup of flour, just multiplied by 8 pancakes divided by 1 cup of flour equals to 2 pancakes. Now this brings us to a critical concept, the limiting reactant. This is the ingredient that gets used up first and limits how much product you can make.
Let's take a look at bowl A. Bowl A has 2 cups of flour in it and it can make 16 pancakes.
However, bowl A only have 1 egg, which is only enough to make 4 pancakes.
The egg is the limiting reactant. So no matter how much extra flour we have, we can't make any more than 4 pancakes.
Now in the other hand, we have bowl B. Bowl B have 1 cup of flour and 2 eggs. And this is the perfect balance ratio. All our reactants will be used up completely with no leftovers. This is a stoichiometric mixture. Now for our last example regarding the demonstration of stoichiometry, we're going to scale our initial recipe to make enough for our whole class of 22 people. Now let's assume everyone gets a pancake, so we need 22 pancakes. Our original recipe yields 8 pancakes. So first, we need our scaling factor, which we can get from this calculation right here. 22 pancakes divided by 8 pancakes gives us 2.75. So our scaling factor is 2.75.
Now we multiply all the ingredients by 2.75. First, we multiply the flour. 1 cup multiplied by 2.75 is equals to 2.75 cups. Next, we have the eggs. 2 eggs times 2.75 is equals to 5.5 eggs. Next, we have sugar. 1/4 a cup times 2.75 is equals to 0.6875 cups, or 11/16 a cup. And then we have baking powder. Half teaspoon multiplied by 2.75 is equals to 1.375 teaspoons. And lastly, we have oil. 1/4 a cup times 2.75 is equals to 0.6875 cups, or 11/16 a cup.
See, we just performed a mass-to-mass stoichiometric calculation, but with cups and teaspoons instead of grams and moles. The principle is identical.
Since we did our explanation already, let's make 8 pancakes with our initial recipe.
First, let's make our pancake mixture, which we will make by mixing our initial ingredients in a bowl.
And we will measure them based on our initial measurements in our recipe.
Now our ingredients will consist of flour, sugar, baking powder, and eggs.
Eggs, sugar, baking powder, oil, milk. Now we mix. Make 8 pancakes.
Wow.
Skip forward, the pancakes are ready, and now we're gonna decorate it using blueberries, bananas, strawberry sauce, and caramel sauce.
So first we're gonna drizzle the
Caramel sauce.
Ooh. Next, strawberry sauce. Lastly, we're gonna add our fruits. You do the blueberries.
Okay.
There you have it. This is our pancake.
So to summarize, stoichiometry is the math behind chemistry.
It uses the ratios from a balanced equation, just like a recipe, to predict the amounts of reactants needed or products formed.
And you always have to watch out for the limiting reactant, or your chemical pancakes might not turn out right. Thanks for watching.